So solving systems of three equations. So I have two screens up because we are going to put some steps on one side as we solve an equation or a system. So if you're kind of writing this in a notebook, I would leave maybe 6, 7, 8 lines before you write your example. So the example we're going to do is 2x minus y plus 3z equals 13 as my first equation, and then x plus y minus z is negative 2, and then 3x plus 2y plus 2z equals 13. So notice that when I have three equations, I have three variables. Or basically, if I have a third variable that I'm solving for, I need a third equation to be able to do this. If I only had two equations and I had three variables, x, y, and z, I wouldn't be able to solve for figuring out what the numbers are. So if there's three variables, you need three equations to be able to solve anything. So my first step is actually done for me. The first step is to line up the equations. Line up the equations. So what this means is, so it looks like ax plus by plus cz equals d. So just the x, then the y, then the z equals the constant d on the other side. So just so everything's lined up. And now in step 2, this is going to be to combine two equations. Combine two equations to eliminate one variable. So to eliminate one variable. So this is like the addition method where I'm trying to eliminate a variable. So, and I'll tell you, I'll wait a minute to write it down, but step 3 is going to be combine two different equations to eliminate the same variable. So it helps to kind of think ahead, like looking at x or y or z, what's going to be the easiest thing to eliminate altogether in those two steps. So kind of right off the bat, I'm looking at maybe y, because the first equation and the second equation, if I combine these right away, the y will cancel out. And then also when I do the 2y with something, it won't be too bad as well. The other good option would be z, because notice plus 3z and plus 2z, we already have the opposite sign. So z would be a good option too. But let's do y. So for y, right away, for step 2, right away, I can combine these two. So I'm going to rewrite them. You might be able to save yourself some writing and some space and do some combining right off of the example, but I'm going to try my best to keep this organized. So right away when I add these two equations together, y is gone. So I'll be left with 3x plus 2z equals 11. Okay, so then like I said, step 3 is going to be to combine two different equations, so a combination of different combination. Combine two different equations to eliminate the same variable. To eliminate the same variable. So, let's see if I can fit this right next to it. So now I want to also eliminate y. I'm going to have to use 3x plus 2y plus 2z equals 13. I have to use that equation because I didn't use that when I combined in step 2. So, so I'm going to have to use the third equation. The other one that will be the easiest to use, it looks like already the signs line up that if I use the top and multiply by 2, I will have 4x minus 2y plus 6z equals 26. So that'll get me to be able to combine these and eliminate the y again. So 2 y's are gone. So I'll have 7x plus 8z equals 39. Okay, so now I've got two equations with two variables. So now step 4 is going to be to solve this system of two equations. So let me rewrite what I have right now. 3x plus 2z equals 11, and 7x plus 8z equals 39. Again, I may be rewriting a little more than I need to, but in order to stay really organized, sometimes it doesn't hurt. So right now what we're going to do is we're going to solve the remaining system of two variables. Which means I'm going to find the remaining system of two equations is what I meant to say. Two equations. So I'm going to be solving for those two variables that are remaining at this point. So it looks like the easiest thing to do will be to multiply the top by a negative 4. So I'll have a negative 12x minus 8z equals negative 44. And then I'll bring the second equation over. I don't have to do anything to that because now I have a minus 8z plus 8z gone. And I have negative 5x equals, it looks like negative 5. So x is 1. Okay, so I got 1. Now the thing is here, I'm still in step 4. Solve the remaining system of two equations. I just realized I spelled remaining wrong as I went and looked at what I wrote. Remaining. There we go. Okay, so x is 1. So I'm not going all the way back to the start right now. I'm just going to one of those system of two equations. So I'm going to plug 1 into the 3x plus 2z equation. So 3 times 1 plus 2z equals 11. So I've got 3 plus 2z equals 11. Subtract 3. 2z equals 8. So z equals 4. So z equals, happened there, 4. So far now I've got x is 1 and z is 4. So now all I have left is to get y. So step 5 is to plug my two known variables, plug the known two variables into an original equation, to find the last variable. In this case, y. And I'm going to finish up the steps and say that after this we'll do a check. Okay, so to get y, I'm going to go back to one of my original equations. So these sometimes get a little big. Let's use a middle equation. So I'm going to plug in 1 for x plus y minus z. Oh, except I know what z is. I can, instead of z, write what it is, which is 4, equals negative 2. So 1 and negative 4 is negative 3, equals negative 2. Add 3. So y equals 1. So I've got my 3 answers. And we can write this kind of like a point where we have x, y, and then the last, we add a comma, and then put the value of z. So 4 in this case. So 1, 1, 4, which means x is 1, y is 1, z is 4. And this should work in all 3 equations. So I'm just going to kind of talk through a check real quick. If you could take your time and write it out. Maybe I'll show a little work over to the side here. So my check. So 2 times 1 is 2, minus 1, plus 3 times 4 is 12. So that's me 1 plus 12, yep, that's 13. And then 1 plus 1 minus 4, 2 minus 4, yep, that's negative 2. And then 3 times 1 is 3, 2 times 1, 2, plus 2 times 4 is 8. So 5 plus 8, yep, that's 13. So they all worked, so we know we got the correct answer for our system.